Okay, in this video we're going to talk a little bit about exponential decay. Before we do, let's kind of look at what exponential growth functions look like and compare it to exponential decay so you know what you're looking for when you see these things. So in the last section we saw that if y equals a times b to the power x, this would be exponential growth. Let's start off by writing that this would be exponential growth if the a value is greater than 0 and the b value is greater than 1. If that happens, it's going to be exponential growth. And just to make a sketch of what's going on here, if you were to actually graph this, you start off with like a small amount and it grows, goes up and away, and it looks something like that. That's growth. Now on the other hand, decay, if we did decay, it's similar. You're still going to have y equals a times b to the power x, so everything's identical so far. However, the a value, although it's still going to be greater than 0, so far again everything stays the same, the b value has to be between 0 and 1. So it's some fraction or some decimal in between 0 and 1, and that makes it a decay model. So what happens here, if you were to graph a decay model, is you might start off very, very high, and then this thing will come down low and approach that x-axis or your asymptote as you go to the right. So it's like almost the reverse of what exponential growth is. Now, on the other hand, you're going to have neither if the following occurs. So it's going to be neither, meaning neither growth or decay, if you have y equals a times b to the x, where a is less than 0. Right then and there, if you see a less than 0, you know it's neither growth or decay. Okay, it's got to have, if it's going to be growth or decay, your a value's got to be positive to begin with. So a couple of questions I might give you on a quiz or test is just to look at some functions and tell me if it's exponential growth, decay, or neither. And essentially, all you need to determine for all of these is, okay, what's the a value and what's the b value? If you know that, and you've studied and you know what those parameters are from above, you'll be okay. In this case, my a value is 1/3, and all that's important with the a value is that it's positive, right? And 1/3 is bigger than 0, so we are in the hunt for either growth or decay. Now the base is 3/2, which is 1.5. That's a number that's bigger than 1. So that looks like it's falling in that growth category. So let's go ahead and identify this one as exponential growth. Let's look at part B. In part B, this is kind of interesting. The a value, you might notice right away, is just 1/3, which once again is bigger than 0. So we're in the hunt for growth or decay. And if you just kind of took this at face value, you might think that your base is 2. But it's actually not. If you take a look, you got a negative exponent there, and that doesn't fit either form. If you take a look at all the forms that we have up above, it's just x as an exponent. It's not a negative exponent. So if we had to rewrite this with a positive x, we would do the following. Think of it this way. It's 1/3 and then 2 raised to the negative 1 times x. Would you agree that's the same as just 1/3 times 2 to the negative x power? I hope so, because it is. You would just multiply the x and the negative 1 to make negative x. But I can now apply that negative 1 power to the 2, making this 1/3 times 1/2, right, if you move the 2 downstairs, to the positive x power. Now I still have the same a value of 1/3, but my b value, you can see, is not 2, it's actually 1/2. And a lot of students get tricked on that because of the negative exponent, and you have to apply the negative to the base and bring the base down into the denominator. Okay, so now our base is actually a half, which does put it between 0 and 1, and that makes it a decay model. This makes it a decay model. Let's do one more together. Here I have an A value of 4 and a B value of 5/8, which I think is like 0.625. It's clearly between 0 and 1. I don't have that negative exponent trick to worry about here because it's just the positive x. And since this is a number between 0 and 1, and my A value is positive, this is another decay model.